value of x and write the input x and output f of x as an ordered pair. Remember, an ordered pair is in parentheses with a comma in between the two numbers. For the given value of x, you will put 4, and then we have to figure out what the output value is by plugging in 4 into our equation wherever we see an x. So remember, you rewrite this, the equation, and replace x wherever you see an x with parentheses. And since x equals 4, we replace x with 4. When we evaluate, we get 71, so our ordered pair, our value of x we plugged in was 4, or our input, and our output that we got was 71. Moving on to 2.2 today, direct variation. And this will help us when we get to graphing lines. At the end of this lesson, you should be able to write and interpret direct variation equations. A vocab word to add to your Chapter 2 vocab list is direct variation, which is y equals kx. We're going to have to solve for k, which is our constant of variation, which means we have to get k by itself. And as we multiply by x, we divide both sides by x, and we get k equals y over x. Notice how it's in fraction form. So for each function, we have to determine whether y varies directly with x. If so, what is the constant of variation and the function rule? To figure out if it varies directly, we have to use our formula to find the constant, k equals y over x. And we plug in for every single one. So we take 2 over 1. And that has to equal 6 over 3, which has to equal 8 over 4. When we reduce all of these fractions, we do get 2, because 2 divided by 1 is 2, 6 divided by 3 is 2, and 8 divided by 4 is 2. So our constant of variation, k, is 2. And to write our function rule, you have to write f of x. You take your constant of variation and put an x after it. So our function rule is f of x, or y, equals 2x. Next, look at B. Set up your proportions. Make sure they all are equal to each other. If not, just say no, and we'll move on to the next example. Hopefully you notice that the first two, 4 divided by 1 reduces to 4, 8 divided by 2 reduces to 4, but 11 divided by 3 does not reduce to 4, so no, this function does not vary directly. These next examples, we have to determine whether y varies directly with x. If so, what is the constant of variation? For y to vary directly with x, remember they have to be in the form y equals kx. Notice how there's no numbers added or subtracted away from our term with an x value. So if we look at our first one, 3y equals 7 over x, we have to get it in this form first. So we need to get y by itself, so we divide both sides by 3. And we get y equals 7/3 x. Since there's nothing added or subtracted at the end, this does vary directly, and your constant of variation is always the coefficient, or the number in front of your x term, so our constant of variation is 7/3. Do the same thing for B. Means we gotta get y by itself, so we divide by 7, and we get y equals 2x plus 1. Again, since we have a number added or subtracted at the end, that means this function does not vary directly, so no. And we are done. There's no constant of variation. Next, we have an example. We suppose that y varies directly with x, and y is 9, x is negative 15. We have to figure out what y is when x equals 21. The easiest way to do this is to set up proportions. So we'll have our two proportions equal to each other. Now remember, when we solve for k, for our varying directly, we'll get k equals y over x. So we have to plug in all of the numbers that we know in this way. So for the first one, we know that y is 9 when x is negative 15. And for the second one, we have to determine out what is y when x is 21. Now remember, when we are solving proportions or fractions that are set equal to each other, we cross multiply. So we get negative 15 times y, which is negative 15y. And then we multiply 21 times 9, which is 189. And we're solving for y, so we need to divide both sides by negative 15. When you reduce it, you get y equals negative 63 over 5. So these are really simple. All you have to do is remember y over x, or just remember, if your y is on top for the first one, your y has to be on top for the second one, and same thing, x on bottom, x on bottom. Next, we have to figure out the graph of this direct variation equation. We have y equals negative 2x. To help us, we can make a table of x, y values. I normally like to pick some negative, some positive, and throw 0 in the middle. So I choose negative 2, negative 1, 0, 1, and 2. And then since we know x, all we have to do is plug it in over here into our equation to find y. So negative 2 times negative 2, we get 4. Plug in negative 1 and we get 2. Plug in 0 and we get 0. 1, we get negative 2. And 2, we get negative 4. Then all you have to do is plot these points, and you should get a line approximately that looks like this. And then you are done. So direct variation does help us when graphing lines. It helps us determine our slope of our line. Come to class prepared to talk about that more tomorrow.